Hi there. In last lesson we looked at basically taking a whole number and dividing it by a fraction. And today we're going to look at dividing fractions by fractions. And we're going to try to do it using a couple of different methods. So for instance, consider the expression 2/3 divided by 1/4. The question is how many 1/4 fits into something of the size 2/3. So 1/4 is the size that the 2/3 is being split into. One skill that I think is very beneficial for you is to try to do estimations, good estimations. So the question here is, can you estimate how many 1/4 can fit into 2/3? So to help you along, I have a couple of scenarios you can think about. Let's suppose you had two 1/4. How much do you have? So if you had like two 1/4, like 1/4 plus 1/4, yep, that's two of them. So that's 2/4 or 1/2. And I'd say that a half is less than 2/3. So when you think of the question, how many 1/4 can split into 2/3? Well, we know it is at least two. All right. Well, what about three? If you had three 1/4, how many would you have? Well, that would be 3/4. And in this case, 3/4 is greater than 2/3. So in other words, if you had three of those guys, you would have more than 2/3. So maybe an estimate would be, just a real rough estimate would be maybe 2.5 1/4 fit into 2/3. Okay, that's just the idea of estimation. Alright, now let's look at two ways we can maybe get to an answer with these kind of questions. The first thing we can consider is the idea of a common denominator. So if we have two fractions that are being divided and they have a common denominator, we can use some reasoning to figure out the quotient or the answer. So consider 2/3 divided by 1/6, where this is the dividend, this is the divisor. So I'm going to rewrite this expression using a common denominator. So I'm going to say that 2/3 times 2/2 is 4/6. So this is exactly the same as saying 4/6 divided by 1/6. So now that we've rewritten it with a common denominator, can we think of how many of the divisors fit into the dividend? So in other words, how many 1/6 fit into 4/6? And that would be 4. So that's the idea that 4 times 1/6 equals 4/6. Alright, so that's one way to think of doing division using a common denominator. Here's the other way and this is the most common way that we actually start dividing by fractions, and it's using the idea of reciprocal. So define reciprocal. A number multiplied by its reciprocal is equal to 1. So 6. 6 times what equals 1? And I think some people would say, well, 1/6. 6 times 1/6 equals 1. That's the idea. What about what's the reciprocal of 28 times 1? So I hope people would say, well, 1/28. That's the reciprocal. Reciprocal of 28. What about 1,528? What's the reciprocal of it? Well, something times that is 1. That would be 1/1,528. So in the same sense, we could have, what's the reciprocal of 1/6 times, well, this would be 6. What is the reciprocal of, say, 11/12? I would say that is 12/11. And we can kind of prove this kind of idea with 11 times 12 times 12/1, or 11. That's equal to 11 times 11 times 12. Da, da, da. can rewrite that like that, and we can see these all cancel out, and we're left with 1. So that's the idea of a reciprocal. For fractions, reciprocal is an inverse, or let's just say flipped. But I don't want to just tell you it's flipped. I wanted you to see how it works in terms of the definition of what a reciprocal is. Okay, so we have a reciprocal. Consider the expression 2/3 divided by 1/6. To find the answer to the above, find the reciprocal of the divisor and multiply. Well, the reciprocal of 1/6 is 6. So that's the idea of 1/6 times 6 equals 1. So it says here, find the reciprocal of the divisor and multiply. So 2/3 divided by 1/6 is the same as 2/3 times 6 over 1, which is equal to 2 times 6 over 3 times 1, which is 12 times 3, which is 4. So in the big picture, this, in the end, this is what you're probably going to use the most when dividing by fractions as you move on through math. Now, why does that reciprocal work? How come we can say that 12? Why can we say that 12 tenths divided by 3/5 is the same as 12 tenths times 5 over 3? Why? And I'll show you why. There's two kind of rules or ideas we're going to use to show that. One is we can multiply a number by 1 and not change the answer. And you can take any number, multiply by 1, and you don't change it. The other idea is the idea of doing division is same as writing a fraction. So 1 divided by 5 is same as 1 over 5. So let's rewrite this as a fraction. 12 over 10 divided by 3/5. Okay. Now what I'm going to do is I'm going to multiply this fraction by 1. I'm going to go times 1. And I can rewrite that by going 12 over tenths divided by 3/5. Instead of saying 1, I'm going to say this is the same as 5 over 3 over 5 over 3. Clearly, 5 over 3 divided by 5 over 3 is 1. So now I'm going to say this, 12 over tenths times 5 over 3 all over 3/5 times 5/3. Well, now we can see that these cancel out to leave 1 in the denominator. So that leaves us with 12 over 10 times 5/3. Ta-da! So it's not magic, it's not some sort of rule that mathematicians come up with to help kids but kind of confuse them. No, you guys could have figured this out by yourselves if you worked at it long enough. We just took these two ideas, that we can multiply a number by 1 without changing it, and writing division is the same as doing a fraction. And we can see that 12 over tenths divided by 3/5 is the same as 12 tenths times 5/3.